Humans spend about 1/3 of their entire lives sleeping. You might think sleep is just when your brain and body take a simple break for a few hours. But actually, sleep is a surprisingly active time for your body. During this period, your body is busy repairing and regenerating itself. Scientists are still studying why the human body is wired to require proper rest in order to perform at its very best. In fact, severe sleep deprivation or constant all-nighters can cause serious damage to your health, sometimes even leading to death. Back in 2013, a research team led by Professor Macon Nettergaard at the University of Rochester discovered something fascinating. Inside a mouse's brain, there is a network of tiny, fluid-filled channels woven like a drainage system. This network uses cerebrospinal fluid to flush out chemical waste. And this cleaning crew shows up mostly when the brain is asleep. Scientists call it the glymphatic system. It plays a key role in removing brain waste, keeping your mind running like a well-oiled machine. Nettergaard's experiments revealed just how critical this waste cleaning system is. When mice were repeatedly deprived of sleep, they lost all immune function and died within weeks. Since humans also have a glymphatic system, and evidence shows that sleep deprivation in humans may have similar effects, let's explore a chilling question. What happens if someone goes to whole weeks without sleep? How will their body begin to break down? But before we get there, we first need to understand how sleep deprivation affects the human body, the focus of countless studies. Back in 2007, a comprehensive report published in the journal Sleep revealed that British researchers had tracked and studied over 10,000 British male civil servants were studied to find the link between changes in sleep patterns and mortality rates. The results, absolutely shocking. Data showed those who cut their sleep from 7 hours down to 5 hours or less had a statistically more than doubled risk of dying from all sorts of diseases and accidents. But the real question is, why? First, lack of sleep messes with your hormones big time. A 2002 study showed that many men with sleep apnea had significantly lower testosterone levels. Sleep apnea causes snoring, cuts off oxygen supply to the brain, and interrupts sleep. This broken, restless sleep disrupts the brain's hormone production. Men sleeping less than 6 hours per night had testosterone levels equivalent to men 10 years older. And that's not all. Sleep loss doesn't just mess with hormones. It also accelerates hair follicle aging. Chronic lack of rest damages the follicle environment, making hair fall out faster. That's why so many people under stress, pulling all-nighters, suddenly notice serious hair loss. Here's the good news. Hair follicle health isn't only about hormones and sleep. It can also be improved with some clever science from the outside. But sleep problems? Well, sleep problems are often just one piece of a much bigger, messier puzzle. The most common sleep disorder, insomnia, is closely linked to mental health issues. In a 2007 study of 10,000 people, those with insomnia were 5 times more likely to suffer from depression than those without it. And in the same study, people with insomnia were 20 times more likely to develop panic disorders. In 2005, a survey by the U.S. National Sleep Foundation revealed that people diagnosed with depression or anxiety often slept less than 6 hours per night, even though these people needed sleep the most. Ironically, reality didn't play along. And worse still, these mental health symptoms can ultimately be fatal. Professor Matthew Walker from the University of California pointed out in his book Why We Sleep that sleep deprivation suppresses the brain's ability to form long-term memories. But here's the scarier part. Chronic sleep loss can have even more devastating effects on memory. The most serious of all, it's linked to the development and progression of Alzheimer's disease. Memory formation is blocked by the buildup of a toxic protein called beta amyloid. The less you sleep over time, the more beta amyloid piles up in your brain. Neural pathways get increasingly blocked. Eventually, these brain circuits malfunction, signal transmission slows down, and cognitive impairment sets in. But the bad news doesn't stop there. According to Professor Walker, if you sleep 6 hours or less per night, your lifetime risk of deadly heart disease or stroke jumps by a whopping 200%. And if you get less than 5 hours of sleep in just one night, the so-called natural killer cells, your key cancer-fighting immune cells, drop by a staggering 70%. Basically, sleep scientists all over the world, sleep scientists everywhere strongly advise, get more sleep. But hey, don't panic. The truth is, you actually can sleep more, as long as you don't have serious insomnia. Adding extra sleep time is one of the easiest positive changes you can make in your entire life. Pretty cool, right? Just resist the temptation of late night scrolling, and you can unlock the achievement, early bedtime. Yeah, I know. For many young people, this might be the ultimate challenge. So now, we already know the health risks of chronic sleep loss and staying up too late. But what if someone doesn't sleep at all? What would happen? In the next thought experiment, let's break it down step by step to see what happens when you completely skip sleep. Scientists have repeatedly studied how long people can stay awake before sleep deprivation really hits hard. The shocking answer, not long at all. After just 16 hours awake, mental and physical performance starts to tank. After 24 hours awake, your brain's cognitive function takes a serious hit. At this point, your driving skills are on par with a drunk driver, along with the tipsy confusion. You'll feel exhausted, get giggly at the weirdest things, lose focus easily, and some people even slip into brief moments of fake alertness, feeling oddly hyper or dizzy. That's because your brain pumps out more dopamine and stress hormones to compensate for the lack of sleep. But after 48 hours awake, that dopamine-driven fake energy boost completely crashes. You feel overwhelming fatigue because your body loses the ability to process glucose properly, and glucose is your main energy source. You start feeling clumsy and uncoordinated. You'll get forgetful, and your hand-eye coordination takes a hit. According to a 2018 study presented at the U.S. Society for Attention and Related Disorders, you may even struggle to read people's facial expressions. If you still refuse to sleep normally at this point, your body will begin slipping into microsleeps. Microsleep means brief episodes of light sleep, lasting anywhere from half a second to half a minute. During microsleep, activity in parts of the brain powers down, while other parts keep functioning as usual. Because of that, you might continue the task in front of you, but you've actually checked out mentally, and often without realizing it. These episodes happen involuntarily, and they often cause confusion. These fatigue-induced lapses in awareness are a common factor in traffic accidents. Hormone regulation also relies on sleep, so staying awake this long leads to mood swings and emotional overreactions. After more than 72 hours awake, things start to get very strange. People who were emotionally stable may begin to show symptoms that resemble schizophrenia. Auditory and visual hallucinations become common. That only adds fuel to the already massive stress and confusion you're feeling. Dr. Mark Nahawald, director of the Minnesota Sleep Disorders Center in the U.S., believes there's evidence suggesting sleep deprivation hallucinations may not be true hallucinations at all. They might be caused by extreme fatigue, blurring the boundary between wakefulness and sleep. In other words, dreams spill over into reality. Nahawald notes that these experiences are similar to the hallucinations some people get when they're abruptly awakened from deep sleep, suggesting the two might be connected. But there's a darker theory about these episodes, which argues they could be manifestations of latent psychosis, hidden deep within all of us. Though this has not been proven, from this stage onward, things get serious in another way. With basic bodily functions impaired, you can't efficiently convert glucose into energy. The body begins to break itself down for fuel. Much like starvation, your system starts consuming any energy source it can find: fat, muscle tissue, and glucose. In the days that follow without sleep, the situation keeps worsening in similar ways. So let's fast forward to the extreme, about 2 weeks with no sleep. And fortunately, when it comes to humans at this stage of sleep deprivation, there's almost no solid research or literature available to reference. However, other studies -1 offer a few clues. For example, mice typically die after about 2 weeks without sleep. It's still unclear whether that's caused directly by sleep loss or by the extreme stress of being forced to stay awake. Either way, it's not good news. There is, however, one human case we can look to. In 1965, a 17-year-old American student named Randy Gardner set the official record for staying awake the longest without using stimulants. He stayed awake for 264 hours 11 days. He did it simply because he was curious how far he could go. During the experiment, his sensory abilities rapidly declined. He lost the ability to concentrate, and he couldn't identify objects by touch. He also experienced hallucinations, irritability, and memory lapses. But surprisingly, after recovering, he showed no lasting psychological effects. And at the end of the trial, He even gave a remarkably clear public speech. That doesn't mean trying this yourself is safe. In fact, not every case of prolonged sleep loss ends this optimistically. Among the few officially documented cases of extreme, long-term sleeplessness, most involve victims of fatal familial insomnia, a rare hereditary disorder. This condition is caused by mutations in the PRNP gene, leading to abnormal prion proteins accumulating in specific brain regions, gradually damaging the neural pathways that control sleep. No matter how hard patients try, or what medications they use, they simply cannot sleep. As the disease progresses, panic attacks become common, along with paranoia and hallucinations, eventually leading to dementia. At the same time, patients rapidly lose weight, and their organs begin to fail. This illness typically results in death within about 18 months. There is currently no known cure, and no proven way to slow its progression. Sleep isn't just taking a break. It's a vital repair process for your body and brain. Plain and simple. Sleeping well is like saving up health in your bank account and stocking up the energy to love life. So to everyone planning to stay up late tonight, do me a favor, will you? Just for tonight. Let's not pull an all-nighter.